Hello, everybody, and thank you for joining us today for Vertica Unify 2021. This breakout session is entitled How Vertica and Voltage Provide Fast, Secure BI and Data Science at MassMutual. I'm Joy King, and I lead Vertica product and go-to-market strategy. I'll be your host for this breakout session. Joining me is Joe Gonzalez, a very experienced and highly valued data warehouse administrator at MassMutual. But before we begin, I encourage you to submit questions during the virtual session because you don't have to wait. Just enter your question into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. And any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. So please stick around to the end and you'll get the code to gain points and participate in our Analyze to Win competition where you can win prizes. Now, let's get started. Over to you, Joe.
It was an honor to be introduced today by Joy King. Looking forward to seeing her again in person next year. She had requested that I give some information about myself first and why MassMutual is using Vertica and how. So my name is Joe Gonzalez. I am a Vertica data warehouse administrator. I've been doing so for 8 years, mostly in the market research and survey industry until starting here at MassMutual as a Vertica DBA in January of 2019. So why did MassMutual choose Vertica over any other product? Clearly, there's plenty on the market, and we could have our pick of what we want to use. Why did we go with Vertica? Very simply, it is the best, most versatile, most powerful, and very importantly, the most affordable data warehouse product on the market. The MPP columnar storage allows us to only query the data that we need, and with all nodes participating in query execution, they complete quickly. And because of that, there is no single point of failure. So even if a node happens to go down, we do not experience any downtime. And with our multiple uses, which you'll see on the next slide, that is very, very important to us, that we do not have downtime that affects not only our internal clients, but our external customers as well. It is platform independent. You can use it on-prem in AWS, Google Cloud, Azure. You can use it connected to Hadoop or on Pure Storage. For our purposes, we initially started with Vertica on-prem several years ago, and about 3 years ago, they moved over to AWS in enterprise mode just before I started. And about a month after I started in 2019, we made the decision to immediately move over to AWS in Eon mode, which has been a huge help for us. It allows us to scale our cluster size, create and scale isolated subclusters for different business purposes, and that is also now available on the cloud and on-prem with the Pure Storage option. Very importantly to us also, it's very affordable. In Eon mode, you get to select and control your hardware, your EC2 instances, and your scaling. So you manage your costs by managing the infrastructure that you are on, compared to we are in the process right now of sunsetting a previous data warehouse product as well. And in that process, we will be saving about 80% of our expenditures. It was several $1,000,000 per year to run on that other platform, about 20% of that on the Vertica Eon platform. So we're very, very happy with that savings as well. It allows us to have better performance on fewer nodes. And on that smaller node set, it allows us to outperform Snowflake, Redshift, or many other competitors at that lower cost. It also allows us to do it faster than the competitors. The place where Vertica really shines is in its concurrency. We do have a lot of concurrent users, and some of those other products cannot handle that kind of load, and Vertica handles it with ease. The in-database analytics functions are what I feel sets Vertica apart from every other product. It has far more predictive analytics, machine learning, and geospatial functions in it. And now in Vertica 10, which is very important to our data science team, and getting them on board with using Vertica machine learning They're now able to import and export PMML and TensorFlow models. Our data science team does use a lot of PMML, and one of their hesitancy was having to fully train models in Vertica, and having the ability to import existing models and export them back out after further training to other internal products was extremely important to them. So I'm hoping they will be using that a lot more in the near future. And one of the biggest benefits to me as a DBA is that they listen to their customers. Anytime there's an issue, they respond very quickly with their tech support. If there's a problem that requires even more, you have access to other people in Vertica, straight down to the actual developers. I've had multiple conversations with developers about features we want to see or problems that we were having that were a little more unique to us. A couple I will be discussing later, and a number of those made it into hot fixes and future versions. So knowing that even as a smaller data warehouse compared to some others, we still have influence over the direction the product takes is quite important to us. So how does MassMutual use Vertica? We do have a wide variety of use cases in our Eon mode implementation. We really do put Vertica to the test. From heavy usage APIs, from microservices. These are driven by people coming into the MassMutual website, wanting to look at different aspects of their financial portfolio. Microservices contact Vertica to get that information back out to the customers quickly. At peak times, we have seen as many as 40 to 50,000 queries per hour. And we have been able to maintain an SLA of 99.99% of those queries completing in under 2 seconds. Most of those actually do complete in under half a second. We have a heavy amount of ETL or ELT processes that run overnight, along with the recent introduction of some Kafka messaging. And our data science teams use Vertica for a variety of reasons and connect using several methods, including R, Python, and Spark. We also have a number of BI and analytics tools that connect: Tableau, Looker, MicroStrategy, that kind of thing, that a lot of our internal users use for reporting purposes. It's very versatile and effective in handling all of those products. So that is, in a nutshell, how MassMutual and Vertica interact on a daily basis. So for our presentation today, this is going to be the agenda. First, we're going to take a look at our road to voltage encryption, general reasons why you would want to encrypt data, why in particular we are using voltage, and why you may want to consider it as well, and a very high level look at what should be getting encrypted in your data warehouse. I'm going to give a very brief overview of the current data ingestion model at MassMutual. Followed by that, we're going to be looking at how to encrypt data in Vertica, setting up voltage, using the UDFs that are included in Vertica, using macros to allow your users to interact with voltage very easily, how to set up the Vertica access policies on columns that are encrypted for security, and some of the challenges that we face using voltage, including keeping track of encrypted fields. We're then going to see how to encrypt files prior to ingest using the voltage file processor as well. And then we'll open up to some questions at the very end. So why should you encrypt your data? 3 major reasons. First of all, legal. A number of recent laws have been passed the last few years, such as the European Union's General Data Protection Regulation, GDPR, the California Consumer Protection Act, CCPA, and New York Reg 187. These require or strongly encourage the encryption of PII, personally identifiable information. MassMutual took it as a high priority to comply as quickly as possible, especially due to New York Reg 187, which deals much more specifically with our industry. There are also financial reasons why you would want to consider encrypting your data. The encryption is not always explicitly required in the laws that I just mentioned, but fines are implemented for data breaches specifically on unencrypted data. And a 2020 study by Ponemon and IBM puts the average cost to a company of a data breach in the US at about $8.64 million. So it costs more money to become a victim of a data breach than it does to encrypt data. Not only are there the costs of cleaning up the resulting mess, you're going to then pay to encrypt your data anyway and shore up your infrastructure to avoid another breach. not to mention the cost of lost business from customers who no longer trust you. That alone can cost many millions more down the line that this study really doesn't consider than simply doing the right thing in the first place by protecting your infrastructure and encrypting your data. And finally, common sense. Hacking and ransomware attacks are all too often. They're still on the rise. We have stories of data breaches and theft far too often and wonder why these companies didn't pay to encrypt their data and secure their infrastructure in the first place. More laws will likely be coming, so do the right thing now instead of waiting to become the next victim. Your data should be protected not only at rest, but in use and in transit as well. It can be intercepted or interfered with at any point along the data pipeline. So why Voltage? There are definitely other viable encryption products on the market. Voltage is not going to fit every use case. It doesn't fit every use case at MassMutual. We initially started working solely with Vormetric, a product that encrypts everything on disk. This is more practical for some of our smaller and lesser used databases and downstream applications. When I discussed Voltage with our then head of Enterprise Risk Management Group, he saw the value and efficiency in what Voltage had to offer, being able to encrypt at the columnar level, the wide application of its use not only in Vertica, but many of our bigger downstream applications, as well as its affordability. So the bullet points on this slide are some of the factors considered in making Voltage our primary encryption tool at MassMutual. So for our enterprise data warehouse, it's already included in Vertica. You just need to activate it with a valid license. It allows for easy encryption and decryption using included UDFs calls, which we will review later in the presentation. It's implemented using Vertica's column access policies, which is invisible to the end users and applications. That is where you set your policies on who is able to see encrypted data in the clear and under what circumstances. Voltage uses format preserving encryption, which is very vital to us because then there's no need to change your table definitions or applications. A date is encrypted as a date, a timestamp is encrypted as a timestamp, and so on. So there's nothing that you need to change in your tables, in your end applications. Format that it goes in at is the format it comes out as. Voltage allows for customizable formats to encrypt the data the way we want it. It does come with several out-of-the-box formats. You can add as many as you want on top of that. Voltage uses stateless key management. There is no key database like there is on many other encryption products. So no key is ever stored on disk. It's only in memory for a very brief time. And this really minimizes the chance of anybody getting in and accessing any master keys that they can then use to decrypt the data in your database. Voltage also has multiple interface options, which allow us to keep data encrypted, again, at rest, in use, and in transit, and allows our downstream applications to be able to easily decrypt data on its own outside of Vertica as needed. For the file encryption option, it has easy integration with our data lake, which is S3. It can be extended to be used with big data technologies like Spark. Again, the format preserving encryption accommodates different combinations of data types, like different timestamp formats, different numeric formats with different XY parameters. It uses the exact same underlying ciphers between the file processor and the Vertica UDXs. So if you encrypt something in a file, load that into Vertica, you can decrypt that data with the exact same ciphers. It's not one set for the files, one set for Vertica. So the flow of the encrypted data is very seamless to users, and it makes it a lot easier on the developers putting this into practice. And again, the out-of-the-box ciphers and the bring your own cipher option really helps encrypt many different types of data formats. So what is it that should be getting encrypted in your data warehouse? Personally identifiable information, or PII, is any data that can be used to identify a specific individual, and it is critically important that this is what gets encrypted. Social security numbers, mailing or email addresses, phone numbers, most commonly being considered PII through the years. But the advances in technology have expanded the scope of PII considerably. So now PII can include an IP address that can narrow down to a single computer, login IDs, social media posts, digital images, geolocation parameters such as latitude, longitude, biometric data like fingerprints, eye scans, and behavioral characteristics. All of this can also be classified as PII, and this all should be strongly considered when deciding what in your data needs to be encrypted. So de-identifying data is another concept to be aware of when talking about encryption. So if all the identifying data leading to a single person is encrypted, other potentially sensitive data may not need to also be encrypted. So we're talking about personal health information, like lab test results, medical bills, health histories, are not necessarily sensitive if you don't know who they belong to. So you can have a value in there that says this person had a bill for $500 for purchasing from whatever store. You don't necessarily have to encrypt that because you don't know who the person is that made that purchase. The same goes for some limited financial data, such as account balances, investment amounts, or even some employee data, such as salary and limited organization information. If you encrypt enough to de-identify the person and not be able to lead down even a full org chart to see where they are in what department, you do not have to encrypt every single bit of information about that person or their organization. So de-identifying data is the key concept to keep in mind. Let's take a quick look now at how MassMutual currently ingests our data. We have multiple data sources. We have a number of database sources, such as within Vertica, using data in one schema to populate data in another schema. Data comes from Teradata, DB2, SQL Server. We have a number of flat file sources that come from SFTP, S3, or Box. We, again, recently introduced some Kafka messaging, so that's another data source, and various REST APIs. The databases can feed into Vertica using Postgres, JDBC, ODBC, and we can load a number of different file formats such as CSV, JSON, gzip, and we've recently been moving away from ORC and toward more and more of our files are being stored as Parquet because that is what Vertica most easily and most efficiently interacts with. So the data from upstream databases outside of Vertica in particular are processed by an internal product that we created called Squark. It's a mixture of SQL and Spark. And what this does is it pulls the data from these databases, lands it in a data lake in S3 as Parquet, and then Parquet then loads that into our Vertica database. The flat files go through a flat file ingestion process through a finite state machine, orchestrated all by Jenkins, which is our scheduling software that allows us to time these and run them once a day, many times a day, whatever. Again, the data all lands in that S3 data lake, and from there, it is ingested into Vertica. We do have some interaction with a couple of other products like Informatica to load data directly through without hitting the data lake as well. But for the most part, this is how we are currently loading our data into Vertica on a daily basis. So how is Voltage going to fit into this process? So before we get into that, why don't we talk about Voltage itself and the product? How do we set up Voltage to work with Vertica? So the first thing you need to do is set up your formats. Voltage comes with a few pre-configured formats: social security number, credit card, salary, that will only accept specific layouts. So for example, social security number format, it must be 9 digits with or without the dashes. The dashes come in, they're ignored, and they are left in place. And the resulting encrypted value can come out as all characters. If you're storing your social security number as a character field, it will make it obviously encrypted, so there's no numbers in there. Or if you're storing it as an integer for some reason, it will spit out a 9-digit number back without the dashes. So users have a wide ability to create custom formats for any number of use cases. And each format you create sets an acceptable alphabet that tells Voltage what input will be encrypted and what input will be ignored. Okay, and only the input that is encrypted is what will be sent back as the encrypted value as well. So the incoming alphabet is also used as the outgoing alphabet. So look at a couple of examples. First would be, say, a phone number format. You would set this up in the Voltage Management Console. You would call it something like phone FPE, and you would set the alphabet as 0 to 9. So this way, any other characters common to phone numbers, like the parentheses or the dashes, will be ignored and remain in place. Phone numbers are, because of that, stored as character. If you're storing international phone numbers, you know that a lot of them do start with a leading 0 for the country code. Setting the alphabet as 0 to 9 and storing the phone number as a character allows a 0 to come back as the first encrypted value without having that 0 lost, being saved as an integer. If you do save your phone numbers as an integer without any of the characters, you would set an alphabet of 1 to 9 instead. So you don't have any leading zeros that are lost. It preserves the 10-digit US phone number format, and any zeros that happen to be in the phone number will remain in place, and it'll encrypt every other number aside from the zeros. Another example would be using the Vertica date only format. So you'll know that Vertica stores its dates as 4-digit year, 2-digit month, 2-digit day. Voltage sets an acceptable year range as a maximum of 500 years. So you can set any date that comes in from, say, the year 1900 to the year 2400 will be what's encrypted. Anything that comes in outside of that date is usually considered an outlier, probably a default date. I know a lot of people do use defaults like 12/31/9999 or January 1st 0001. Those will remain unencrypted and untouched because they are default garbage data, so there's really no need to encrypt them anyway. Anything sent to this particular format in any other format, so say you send it month, day, 4-digit year, it will most likely be rejected if you send it in that format as well. So you have to be careful maintaining the format of the date when sending the value to Voltage. The final example is the catch-all alphanumeric format, basically to catch anything that you may be storing that just happens to be alphanumeric and really doesn't fit cleanly into any other category that you want to set up. You would set your alphabet as 0 to 9, capital A to capital Z, lowercase a to lowercase z. Those will be the only values encrypted. Symbols and special characters will be ignored and remain in place. So that is how you set up your formats. The next thing you need to do is set up identities, okay? It's the combination of a format and an identity is what will create a unique encryption using the master key that you set up for your Voltage server, okay? An identity can be anything you want. It's just a name. It doesn't really have much of any function other than to set a uniqueness to a certain combination of format and identity for a unique encryption type. Again, it could be anything you want. Try to name it appropriately to what is being encrypted. So for example, using the alphanumeric catch-all that we discussed on the previous slide, use that to encrypt names and addresses uniquely. So for name, you would use the alphanumeric FPE format that you set up and use an identity called Voltage name. For address, you would use alphanumeric FPE and identity Voltage address, okay? And we'll look at the UDFs later and see how this is exactly passed in. But encrypting the text, say test text for encryption, will result in a different encrypted value for each of these two combinations above. So I ran that through Voltage with a test key, and this is what came out for name. You'll see the format is preserved. So 4 letters for test, for text, 3 for the word for, and then for encryption. Using the name alphanumeric FPE combination, you get 1 encrypted value. Using alphanumeric FPE with Voltage address identity, you get a completely different encrypted value. So if you want to send your names to one, send your addresses to another one, you can separate out city, separate out state, zip code, whatever, however you want to separate them out based on how many you have in your data warehouse. This is how you do it. This makes it much more difficult for anyone, say, who does happen to hack into your data warehouse. Not only are they going to have to get access to your master key, which is not stored on disk, they're also going to have to know all of your format and identity combinations. They can't just get one master key and decrypt everything. They have to go and find each individual combination, figure out which columns are encrypted using those combinations, and figure out how to decrypt them using that. So it really adds to the complexity of anybody trying to get into your data. So let's take a look now at the UDFs for Voltage that are included in Vertica. There are 2 for configuration and 2 that actually do the encryption and decryption. Okay, so let's look at the configuration ones first. First is Voltage Secure Configure. For this one, you're going to set 3 parameters typically. The first one is going to be the path where your configuration file that you're setting up here is stored on your Vertica nodes. And this path that you specify is not kept in root. It's kept somewhere deep within the Vertica folder structure. It is encrypted. It is almost impossible to get to and is even more impossible to tell what is in there because of the way it's encrypted. So it's not something you could just go find this file and edit it manually. It can only be changed through these UDFs. So the first thing you do is pass the path where you want that stored. The second is going to be your master identity, and you're going to state also whether you want to store your shared secret, and that's your master key. If by doing so, again, it's encrypted, so it's safe, but it allows people to come in and use the Voltage Protect and Voltage Access UDFs without having to set these parameters at every session and know all this information. And you really don't want your users having to know and worry about all this information. Set it globally so they can just use the UDFs on their own. The second is the Voltage Secure Configure Global. The first parameter you're going to pass here is a policy URL. So all those formats that we discussed in the previous slide of setting those up in the Voltage Management Console, once you're done with those, you'll do in the management console is called a deploy, and it'll deploy it to a client policy.xml file on the Voltage server that you're using. So you're going to tell it what the URL of that XML file is. It's not a secure file. All it does is tell what the different formats are and how they're set up. There's no keys or anything are stored in there. And then the other parameter that we use is allow short FPE. And we set that to true. What that allows you to do is typically Voltage comes with, I believe, a 3-character minimum in order to encrypt a column. So if you're passing in like a Boolean 0 or 1, it's going to reject it out of hand. Say you do want to take that extra step and take no chances and encrypt a gender column that only has M or F or a single character designation for gender. You would have to set your allow short FPE to true in order to allow that. It'll overwrite the default and allow you to encrypt a single character column. So those are the two configuration ones. After you set up your formats, you're going to deploy that. You're going to run these two as a DBA, and that should be the last time you'll ever have to worry about those, unless you ever change your FPEs. If you add another one, you'll have to redeploy and just rerun these. That's the only time you'll have to worry about those. The other two are the ones that actually do the encryption. So it's Voltage Secure Protect and Voltage Secure Access. So the first thing you need to do is pass in the value that you're encrypting. Voltage only allows this parameter to be a varchar field. So whatever you have, so whether it's a date, timestamp, or whatever, it has to be cast to a varchar. And then when it comes back, you're going to have to recast it back to its original data type. So value goes first. Second, you're going to pass in using parameters, and then you're going to pass in the format that you're using, the format name, the file name, the path of your configuration file, and the identity that you're using to combine with the format name in order to do the encryption. In the Voltage Secure Access, you're passing in the exact same information, but the value that you're passing in is the actual encrypted value. Voltage Secure Access will then use that information to decrypt it back to its in the clear state. So again, you really don't want your users having to worry about that configuration path and passing it in. So in part, thanks to us and a couple of other clients, working with Voltage as of Vertica version 10.0, they included some documentation to have you set up SQL macros to allow your users to have an easier experience with Voltage. So one, you don't want them remembering that DFS path for your configuration file. And the casting to varchar and back to the original data type can also be rather cumbersome for the user. So what you want to try and do is set up some macros to do that casting for them. So we have a couple of examples here. There's some more examples in the Vertica documentation that you can look at as well. So what the first one does is it takes an actual character value, and this is the Voltage Access, so this will actually decrypt the value. So you pass in the value that you want decrypted, and then you're going to pass in a crypt ID that identifies what category that data falls under. So in this example, you see we have this set up for 3 potential categories: Social Security number, person's full name, and an email address. If you pass that in, it'll look for, in the case statement, which crypt ID type it is, and it'll do the decryption based on that. So it'll send in the value. Your configuration path will be set up in this UDF already, so no need for the client to worry about it or the user to worry about it, and then the identity that you're using, and it'll pass back the decrypted value. Same for full name. For email, you're changing the identity. See, everything is the same. You see the formats are different, So you have your SSN FPE, your name FPE, and your email FPE formats. And then your identities are for social security number, name, and email identity as well. And that will guarantee, again, a different encryption type for each item that you pass in based on that crypt ID. So the second one gives an example of encrypting a non-character field. So here we're going to do a voltage protect passing in a date. So you're going to pass in the data purpose, you're going to pass in the date value, and you're going to return a date. So you're going to see here the difference is that the value in the voltage secure protect call inside the UDF is doing a cast to varchar. And once it's encrypted, it's casting it back to the date so we can pass that encrypted date value back to the user. This way the user does not have to worry about doing it on their own. This has made our developers' lives a lot easier. We had started out originally using the Voltage Secure Access and Voltage Secure Protect. They were having a very difficult time using it. We now have several different macros set up, one for character, for date, for timestamp, for integer, and numeric. So they can just call whichever one they need to, appropriate to the data type of the field being encrypted, pass in the proper crypt ID, and they only have to worry about those two parameters being sent in. So once that data is encrypted, how do you determine who gets to see that data in the clear and who sees it permanently in its encrypted format? And that is going to be set up using your Vertica columnar access policies. So in our current usage before moving to Voltage, we were doing this by masking the data. We also did that using the access policy. The example that I give here is we're creating an access policy on test schema account info table, looking at the first name column. You're going to say when your enabled role is dbadmin, or what we did was we set up a specific role for seeing data in the clear for test schema underscore UA. So for each schema that we have an underscore UA role for unencrypted access. If you belong to that role, you're allowed to see the data in the clear, or if you're a dbadmin. If you're not, you see the masked data. So it checks first to see whether you're in that role, or if you're a dbadmin, then it sends you the first name in the clear. Otherwise, it just sends you a specific text that says masked, and you don't get to see what's actually stored there. There's no effect on how the data is stored using a masking access policy like this. The data is stored in the clear. It is not encrypted. It is not secure. All you're doing is affecting the data as it is displayed to the end user, depending whether or not they're in one of those two roles. So taking that next step now, we want to encrypt the data and change that access policy to use the voltage UDFs. So the first thing you do is you update that table and set the first name to voltage protect first name. So that updates all the values in that column with their encrypted value. That is now what is stored on disk. Without an access policy, no matter who queries the data, whether you are a dbadmin, a super user, a regular user, you're going to see that data encrypted. The only way to see it unencrypted is to call that data using the voltage access policy yourself, which is why you really want to lock down who has access to the voltage protect, especially the voltage access function. You don't want users just using the voltage access function unless they really have a business need. So the second thing you're going to do then is to update your access policy. So you're going to drop the original, you're going to recreate the access policy on that account. Okay. Same for the column first name. You're going to do the same check for roles, whether the person's in that unencrypted access role or if they're a dbadmin. Instead of passing back just the name, you're going to then call the voltage access function and decrypt the value and send that back to them. Otherwise, you're going to send back first name as it is, which is its encrypted value. So if you don't belong to one of those roles, you see it encrypted. Otherwise, you see the voltage access decrypted value of that. So when you put an access policy on a column, it does affect who is able to do DML operations. So on a masking policy, any user who's allowed to see the data in the clear is allowed to do deletes, inserts, updates, and whatever on that table. For voltage, it kind of got a little mixed around so that anybody who sees the encrypted data were the only ones who were able to do inserts, updates, and deletes on that table. So we had a conversation with Vertica, pointed that out to them, had a really nice long discussion with the developer who was in charge of the access policy coding. Thanks, Yuanzi, really appreciate it. So what they did was they added a new parameter in 10.1, just recently came out, called grant trusted. What this does is at the end of the access policy, before you say enable, you're going to put the words grant trusted. What that does is it ignores the conditions of the access policy and strictly relies on the grants of the schema of that table to determine who is able to insert, update, and delete data in that table. So if you have that access normally, regardless of whether you're able to see the encrypted or decrypted data, you're allowed to insert data into that table. So we're happy to say that we were one of the driving forces behind that change, which is now in place, and it's making our lives a lot easier on this end here. Challenges. The biggest challenge that you're going to face when using Voltage is that you need to have a way of keeping track of what fields are encrypted. So Vertica and Voltage currently offer no way to keep track within the database, like a flag or anything, of what columns are encrypted. And for security purposes, it actually makes sense. It does sound like a hassle, but you don't want somebody going in and seeing some sort of flag saying, okay, these 3 columns in this table are encrypted. Those are, so they know where to target. So you don't want that. So what we did, you're going to have to come up with your own solution. So we followed the lead of other users using this and created a column metadata table. You're going to keep this in a schema with very limited access. You want to limit loading into this table to either one user or to a service account controlled by a small central team dedicated to managing the Voltage processes. And you can, again, encrypt that data so that anybody unauthorized can get into that table. They're not going to see which columns are actually encrypted. But you do need some way of figuring that out. And so in this table, you're going to store all the relevant columnar information, the schema, the table, the column name, and the data type. And you can also store the relevant encryption info related to the column. So the cipher, that, type like the SSN or name or address, what type of category it belongs to, and then the format and the identity that are being used to encrypt them. And those fields in that table are most likely, again, going to be encrypted themselves. You can then use this table to keep track of everything that's encrypted, and you're going to have to be diligent about it. You're going to have some very strict policies in place of inserting it to this table, updating it when tables are removed, or coming up with some sort of way to keep it clean. And you can use this information then to put in a bunch of information about columns being encrypted and create a script that will then generate your create access policy statements for you instead of having to manually create every single one. All the information you need to create an access policy is in here. There's really not too much to be concerned about that, because anyone that has permission to those UDFs can encrypt the data, but the only ones who can create the access policy are DB admin and other super users. So it is very, very limited to who can actually put that access policy on. So the DBA is typically going to be involved in managing a decent portion of this. Or again, you're going to designate one person on your Voltage team to have that kind of ability. So this leads to a discussion about our encryption solution using the Voltage file processor. So that was all how we encrypt data in Vertica using Vertica. What about the files? Because you want your data, not only your data warehouse to be encrypted, you also want the data in the files that you're storing in S3 or on disk, whatever you're using as your data lake, to be encrypted as well. So we use the Voltage file processor. File processor is Java-based. We've integrated it with Spark so that we can encrypt large data sets by spreading it out over a series of worker nodes. We do have some data sets that are hundreds of gigabytes in size and do take a bit of time to go through the encryption process. So within the metadata catalog or Vertica, we have that column metadata table that I just discussed, which contains the information about whether a column in a data set is flagged for PII. So not only in that column metadata table are you going to store information about your Vertica columns that are being encrypted, you also want to store in there what file columns are being encrypted. You'll then pull that information out of there. We store it as a JSON file that the Voltage file processor then reads in as input along with the dataset location, the file location in S3. It uses that bit of information, then go into the file and encrypt only the columns that you specify. So it doesn't encrypt the entire file. Much like the Vertica tables, it only encrypts the columns that you want encrypted, which is fantastic. It cuts down on time, it cuts down on overhead, and makes loading a lot easier. Once that file dataset is encrypted at the column level, we then write it back to an encrypted data lake bucket, which is then used for loading the data into Vertica physical and or external tables. Again, this makes the data flow a lot easier on our developers, on our ETL teams, because you can then just encrypt the data at the file level and load that data pre-encrypted into Vertica without having to worry about using the UDFs to encrypt it on the way in. So this is our general ETL framework for execution within Vertica. The in-database ETL performance we rely on due to data locality and resource pooling. Basically, this accepts SQL files from projects as input, leverages the metadata catalog table for source and ETL mapping info, and then loads the data to our EDW target table. So basically, this is the last portion of the previous slide that I was talking about, where the data is encrypted by the file processor, stored in the S3 data lake, encrypted. Our ETL processes then load that data into our staging tables already encrypted. And then the ELT processes then transform that data and then merge it into our end tables, which are the dimension and fact tables. You can do this one of two ways. You can keep that data encrypted all the way through the data pipeline, which is the easiest. If you need to use any of that data in the clear format anywhere along that pipeline, you can decrypt it, do whatever transformation you need on it. So say you have your date field for somebody's birth date. You can decrypt it, determine their age, store the age, and then in your final table, re-encrypt not only the birth date, but also the age field as well. So that is how we are pulling that data in from the data lake and how it stays encrypted or is used, decrypted, encrypted across the data pipeline. And finally, we're going to take a quick overview of all the ways that Voltage is going to be implemented across our data platform. So starting at number one, you'll have a number of applications, data sources, where the data is unencrypted. It's going to come in and you're going to load it directly into Vertica and encrypt it using those Vertica UDFs. So that's one way of loading the data in. Some of the applications that are also using it, having unencrypted data, that data will be pulled out and landed as S3 files. Voltage will then encrypt that data in place in S3 and then load that data into Vertica pre-encrypted. There are a handful of upstream applications in number three that are also going to be using Voltage. They're going to be using the same ciphers. They're going to be connecting to the Voltage servers independently on their own outside of Vertica, using the same ciphers, the same formats, the same identity combinations. The data is going to be encrypted already in those applications. We can just pull it into Vertica already encrypted that way as well. So those are the three different scenarios of pulling data into Vertica. Getting data out of Vertica, many of our downstream applications, such as analytics platforms, reporting tools, simple ad hoc queries by our users, that kind of thing, the majority of them are not going to have any requirement to see any of that encrypted data in its clear format. So they're going to run their queries, they're going to pull the data, it's going to remain encrypted. There's no reason for any interaction with Voltage whatsoever. Second scenario is the usage of the access policies and the Voltage access UDX, pending the user and pending whether they are in that unencrypted access role that you set up in Vertica. They can see the data in the clear as they query down and pull it over. You're going to have some strict guidelines in place as to what they do with that data on their end, a way of policing whether they're encrypting it, if they're storing it locally somewhere else, if they're showing it in a report. And there's going to have to be separate encryption policies for any of these downstream applications outside of Vertica. So you're really going to have to manage this well. These are going to be managed again by those Voltage access policies. And finally, you're going to have some applications like Tableau, like MicroStrategy, where you have a Tableau data extract, pulls the data and stores it locally on the Tableau server. MicroStrategy Cube, same thing. You pull the data out of Vertica, you're going to store it on the MicroStrategy server. We're going to take that data out and store it already encrypted on those servers. And then Tableau and MicroStrategy, or whatever other platform you're using, they're going to have their own security policies, their own interactions with the Voltage server, so that any users coming in will interact with the Voltage server, typically through Active Directory, their logins that way to determine what groups they're in, to determine whether they can see the reporting data in the clear or encrypted. And that's all going to be managed within Tableau, within MicroStrategy, and leave Vertica out of it. But the data will be stored encrypted on those servers, which it should be. And that brings me to the end of my presentation. So I thank you all very much for taking the time to spend listening to this presentation. I hope you learned some valuable stuff here. I hope a lot of you who aren't already using encryption and have any data such as PII in your data warehouse strongly consider encrypting that data. Remember, getting your data encrypted is worth the upfront investment. It's going to cost you a lot less to do that and shore up your infrastructure than becoming a victim of a data breach where you're going to lose money, lose business. So really consider the upsides of encrypting your data whenever and wherever and as soon as possible. Thank you all very much. I do appreciate your time.
Thank you for listening to our presentation. Now we are ready for Q&A. Joe, I have to tell you that when you said that last comment about the cost of not encrypting your data and losing, the cost of ransomware and things like that, I think the biggest cost that companies don't take into account, but is really the highest cost, is the loss of consumer or customer trust. One breach, and that trust takes forever to rebuild, and that cost is truly epic. So I couldn't agree with you more that you have to assume it's not an if, it's a when, and making sure that the data truly is protected. So
Absolutely,
congratulations
because it's
to
going
you
to
on
cost the
that.
customers too. Thank you.
Exactly. Yeah.
Yeah.
So as you can imagine, the questions that came in, we don't have a lot of time, but the questions that came in are exactly what you would expect related to performance. So
Sure.
the first one really is, do encryption, decryption processes affect your BI dashboards, performance generation, things like that? How does it affect the dashboards and performance that you rely on in Vertica?
Well, I'm actually going to, the answer that I give is actually going to answer both of the questions that are up there. There's the other one about query performance
Okay, good.
degradation.
Yep. Mm-hmm.
So
Yep.
you're going to notice there's going to be some sort of degradation, but it is minimal. We did a bunch of testing on um, uh, pulling, hundreds of millions of rows from a table where the data is encrypted. It has to be decrypted on the way out. And at any time, the most we've ever seen was between 2 and 3% performance degradation. So slightly noticeable, but not enough to affect your end users. And any testing that we've done with a couple of reports that we have been using against some of the tables with the encrypted data, it's been minimal to the point where users don't even notice. So again, you're probably going to notice about 2 to 3% degradation.
Okay, so it's a relatively minor that your users don't really notice, but obviously the very small sacrifice is worth it.
It is, and the reason for that is because it's a stateless key management system. It calls the key once, it pulls everything over one time, it does all the encryption in memory, the decryption in memory, and releases the key from memory. Whereas other products call it for every single row that has to be encrypted. Those are the ones where you're going to notice the performance degradation more. Voltage does not do that.
That's a good point. So now this is more of an administrative headache question. If I have dates and timestamps stored in different formats in my database, will I need a voltage format for each one?
For the most part, yes, you're going to. If they're close enough that the format that you set up can handle both of them. If you got year, 4-digit year, 2-digit month, 2-digit day, some storing with slashes, with dashes, with no character in between, those can usually be handled by one because you're ignoring those characters anyway. If you have a date time stamp format where it always stores it in 24-hour format versus one that stores it in 12-hour with an AM or a PM, you may need separate ones for those. In most cases, you're going to be storing the timestamp the same way across your database anyway. So you're only going to need the
Okay.
one. But in the cases where you don't, yes, you're going to need separate formats.
Okay, so now I'm going to pivot to more of the non-technical but people question. One of the things that you pointed out at the beginning, and I know that this is something that is equally as important as the technology, is the people. You made a point that Vertica as a team really listens to its customers, really, and there's been some bumps along the way as we've worked together.
Oh, yeah.
Tell me about what you admire or really value and that you think the audience should hear about Vertica culture or Vertica people and Voltage team, the Voltage team too, in terms of working together.
Definitely. For me, I appreciate the personal touch. I've been working with Vertica databases for 8 years. I've been working with the same people for most of those 8 years, so including yourself. So it's become a bit of a family for me. But the attention that they give, it's not just based on who you know. It's not just because I know these guys. It is other customers too. And if you're having a problem, they'll get their best people on it. They will pay attention to what you're saying, and if it's a problem with their product, they will fix it. We had a minor problem with our, a recent upgrade where there was a problem with the uh, uh, calling voltage access within voltage protect. It just happened to be that because of the way we set up those UDFs, they were set up as volatile, and we couldn't change them to stable. And you can't call a volatile function as a parameter to another function. They put in a fix for that because it was being caused by the throw error portion of that UDF. Within a week, they had a hot fix for us before we made our jump to the production upgrade. It was fantastic. They worked with us to figure out what the problem was, how to fix it, and we had the hot fix. And it's not the first time that's happened with us. So I really
It's
appreciate that. I
funny.
don't think I've ever had that with any other company.
Oh, that is great to hear. And I have to tell you, every time I rave to our engineers about how positive the feedback is from this customer I met or that customer I met, they say, yeah, but could we do better? Don't you, is that
Yep.
all you can think about? So
They do. They absolutely
it is.
do. No question about it.
It is special. So we are actually out of time. I do want to remind both of you and me, Joe, that we met at a Vertica Big Data Conference many years ago. And
Second one,
I am
yep.
really looking forward to seeing you in person next year in Boston for Vertica Unify 2022, because I really think that circle's going to get closed.
Definitely, and I guarantee you I will be there.
Okay, that's a deal. Well, thank you everybody for joining this session. Now, as I shared during the keynotes and you've read on the platform, you have the opportunity to earn points, to earn prizes, and important to me, contribute to helping a dog and protecting and saving its life through our contributions to Out of the Cage. So the code for today's session, for this session, is Poodle, Poodle. Enter that code into the Analyze to Win platform, earn points, earn prizes, and make a difference in a dog's life. And remember, protect your data because your customers rely on you to do that. Thank you all, and we'll see you soon tomorrow.